Hey guys, it's Tanya from Trio Student Support Services here at Rose State College. And this video I'm going to be talking about several concepts that are covered in Chapter 2. So in Chapter 2, I just want to prepare you for scientific notation, significant figures, converting between units, and density. So there are several parts of this, and my job as a mentor and a tutor is not to lecture the material that your professor is going to be teaching, but rather to reinforce some of the concepts and work through some of the problems, just to show you a different way of working these homework problems. That's another thing too. You guys are definitely going to want to print out those homework problems and work through them as your professor lectures on each different type of problem that's on that homework sheet. They don't collect these for a grade, but they do use those same problems on quizzes and exams. So it benefits everybody. It benefits you because you know what to expect, and when you sit down and take the quiz or you sit down and take the exam, you may have seen that problem before. So the first thing that we're going to talk about today is scientific notation, and I'll show you what that is and how to express a number in scientific notation. So scientific notation looks like this. So you have your decimal part, which is your 1.2, and then you have your exponential part, which is your 10 to the negative power or your 10 to the positive power. So just one thing to remember is that a positive exponent means 1 multiplied by 10 n times, where n is your exponent, and a negative exponent, which would be a negative n in this example here, means 1 divided by 10 divided by 10. See? N times. Okay? So let's work through a few problems on scientific notation. We'll go through a few example problems, and that way you'll be prepared for the homework and for your quizzes. I think the professors usually do about 1 quiz a week, so these videos will help you out with those quizzes. I think I've been doing them. This is my 3rd semester doing these videos, so I think they're pretty good. I think they're pretty helpful. Some people like them. Alright, so what we're going to do is we're going to take a couple of numbers here and put them into scientific notation. We have this one here, 36, 756, 000, 19, 258, 0.25, 1, 2, 3, 4, 5, 583, 10.9. Okay, so go ahead and write these down. Take a moment to pause the video and put these in scientific notation. Just remember that the goal of scientific notation is to reduce these numbers down to a number between 1 and 10. So it makes it easier to write, because if you had to write this number multiple times, your hands would probably cramp up. So that's the goal of scientific notation. Like I said, I'm not going to lecture. I'm not here to teach. I'm just here to show you how to work the problems. So pause the video, and when we come back together, I'll have the answers on the board. Okay, so scientific notation for the first one is 3.6756 times 10 to the 7th. As you can see, we moved our decimal point 7 places to the right. So that gives us a positive exponent. Same thing for number 2. We moved it 4 places to the right, and we have a positive exponent. When you're moving your decimal to your left, you're always going to have a negative exponent, because that's dividing, right? It's 1 divided by. So we're trying to make this number smaller, so we have 5.83 times 10 to the negative 6th power. So if we were to divide this by 10 to the negative 6, this is the number that we would get. And then we also have this one here, 3.56 times 10 to the negative 3. So just remember, to the right is positive, to the left is negative. Okay, just a quick tip. All right, so I am going to show you next significant figures. So just a couple of different tricks for putting numbers into significant figures and then how to use those in calculations. Okay guys, so for significant figures, now you'll find this if you're using the 6th edition of the introductory chemistry textbook. On page 20, there's a list of these rules, so you don't really have to write these down. I just thought I'd write them down to show them to you. But the first rule says all non-zero digits are significant. So in this example, 1.05, the 1 and the 5 are significant. And 0.0110, the 2 ones are significant. And then rule number 2 says that interior zeros, so these are going to be zeros that are between 2 numbers, are significant. So for this figure, 4.0208, these 2 zeros here are significant. So if we were to count the number of significant figures, it would be 1, 2, 3, 4, 5. So there would be 5 significant figures in that number. And then for this one, this is an interior zero, 50.1. This is a significant figure. Number 3 says that trailing zeros that fall after a decimal point are significant. So you have 5.10, 3.00, where the zeros are significant. Okay, so let's take a look at the next couple of rules, 4, 5, and 6, and then we'll work through some problems. Okay, so rule number 4 for significant figures says trailing zeros that fall before a decimal point are significant. So they are significant. So in this example, we have 50.00. This 0 right here is significant. Okay, and then in this figure, 1700.24, these zeros are significant. But then you have zeros that are to the left of the first non-significant number, and they are not significant. Okay, so let's look at one more rule, and then we'll work through some practice problems, like I said. Okay, so rule number 6 of significant figures is perhaps one of the most important rules. And like I said, I didn't put these rules on the board because I wanted you to write them down. I do want you to reference them. Maybe get a post-it note or flag it in your book if you have the textbook. If you don't have the textbook, by all means, please write these on a flashcard and study them, because you may or may not see these on a quiz or an exam from your professor. So rule number 6, trailing zeros at the end of a number but before an implied decimal are what we call ambiguous, and they should be avoided by using scientific notation. So you have the figure 350, and when I say implied decimal, we're just assuming that 350 is the only number and that there is a decimal here, right? So this could be $350, $350, whatever. But we're assuming that there is a decimal here after the 0. So this would be considered a ambiguous number, and we don't like ambiguous numbers in science, especially we just don't like them. So we want to write this in scientific notation, and we can do that by moving the decimal 2 places and making this 3.5 times 10 to the second. So That is scientific notation. Let's take a look at a couple of practice problems. So let's take a look. We've got 5 practice problems on the board here. Go ahead and jot these down, or maybe you can work them out in your head. Pause the video, and when we come back together, I'll have the correct number of significant figures identified for each one of these problems for you. And then we will go on to our next topic, which is going to be using significant figures in calculations. So it's a little bit different when using significant figures when we're multiplying and dividing, or adding and subtracting. So I want to show you a couple of example problems, and then we'll do some conversions, and then we'll be done with the video. Hey guys, just like I promised, put the answers on the board here for you on your significant figures with your practice problems. If you're working through these practice problems and you get tripped up or you're not sure about a rule, refer back to that page 20 in the 6th volume of your Intro Chem textbook, or you can rewind the video and see where I posted the rules on here. Just as a reference, you can write them on flashcards and study them, because you may or may not see a question about the rules on a quiz or an exam. Okay guys, so earlier in the video we talked about significant figures and how to identify those significant figures and what the rules are associated with them. When you have significant figures in calculations, there are some additional rules. For multiplication and division, your significant figures are going to be, your result is going to carry the same number of figures as the factor with the fewest significant figures. So here's an example. So you have 5.02 times 89.665 times 0.10. And I've broken this down for you. You'll see that there's 3 sig figs in this first factor, there's 5 in the second factor, and there's 2 in the third factor. And so based on this rule, when we multiply these 3 factors together, we get 45.0118. The factor with the fewest significant figures was 2, so our answer is going to have 2 significant figures. Okay? So there are additional rules for rounding and addition and subtraction. So let's take a look at those now. Okay, so you've learned this in every math that you've ever had in junior high and high school, and maybe even elementary school. But rounding, you round down if your last or your leftmost number is 4 or less, and you round up if it's 5 or higher. The thing that you have to remember with rounding is when you have multi-step problems, you don't round your intermediate product. You wait until your final calculation to do your rounding. If you round your intermediate product, then you're going to have a wrong answer. So we're going to take a look at one more rule for significant figures and calculations, and that'll be for addition and subtraction, and then multi-step, including multiplication, division, and addition and subtraction, and then we'll do some practice problems. So let's take a look at those additional rules now. Okay, so with addition and subtraction, the result has the same number of decimal places as the quantity with the fewest decimal places. So I've put 2 examples up here, and what I've done is, and so that I can keep my place and determine the factor with the fewest decimal places, is I've just drawn a line down here. So when I do my calculation, I come up with 124.867. My factor with the fewest decimal places is this one right here, 125.1. So my answer is going to have 1 decimal place. So my answer here is going to be 124.9. And why is it 0.9? Because this number here is 6, so it's 5 or higher, so I'm going to round this number up to 9. And then looking at this subtraction problem here, we've determined that our factor with the fewest decimal places is this one here. So I've drawn my line, and I know that my answer is going to be 8.66. So that's 2 places after the decimal, because this 4 we rounded down. So it's negative 8.66. Okay, so when you have significant figures in calculations that involve both multiplication and division and addition and subtraction, you always want to do your steps in parentheses first. Then you're going to determine the correct number of significant figures that are in your intermediate answer. You don't round yet. You're going to complete your remaining steps and then you'll round your answer. Okay, so I've put this problem on the board for you, and as you can see, based on these rules, you're going to do the steps in parentheses first. So you're going to subtract your 2.3 from 5.67, and that's going to give you an answer of 3.37, right? And so you have one significant figure after the decimal point based on the factors that are in parentheses. So then your next step would be to take your 3.489 and multiply it by this number here, the 3.37, and that's going to give you an answer of 11.758. Now we know from this step right here that we only have one significant figure after the decimal point. So that changes our answer here, right? So this is going to be our stopping point. Our one number after the decimal point is 7. Well, because this next number here is 5 or higher, we're going to round this up, okay? And so our answer is going to be 12. So here's 3 practice problems for your significant figures calculations based on the rules that we just discussed. Go ahead and work through these 3, pause the video, and when we come back together, I'll have the answers on the board. These are the type of problems that you can expect to see on a quiz or an exam. So it's a good idea to get started on those homework problems now. Get lots of practice on these sig fig calculations. You need to be able to work through these quickly and know those rules by heart, so you'll know what steps to take at appropriate times. So go ahead and pause the video, work through these problems, and when we come back together, I'll have the answers on the board for you. Okay, so I've put the answers up here in red. So the answer for number 1 is 110.6. As you can see with our factors here, we determined that the correct number of significant figures after the decimal point is 1. For problem number 2, we worked the problem inside the parentheses first, then we divided, and we came out with 86.1. Same thing for number 3, we did our problem inside the parentheses first, then we subtracted to get 7.61. Okay guys, so basic units of measurement is what that's going to be the next topic, and you'll find these basic units of measurement if you're using the 6th edition Intro Chem textbook on pages 26 and 28. You have your SI prefix multipliers that are going to be table 2.2, and then your common units and their equivalents are table 2.3. So not going to go through that and talk about that. We need to jump right into unit conversion and dimensional analysis. And so dimensional analysis is something that is fun. We use it on a daily basis, we just don't ever realize it. So what is dimensional analysis, you say? So it's using units, and you're going to need to know the definition, using units as a guide to solving problems. Okay, so the reason I point this out is because anytime you're working conversion problems where you're converting from one unit to the next, units, you must always include the units. In your answer. If you don't, your professor's going to count it wrong. Okay? So what is dimensional analysis? What is unit conversion? Let's take a look at that, and it'll start making more sense. So let's go ahead and take a look at that next. Okay, so when we are converting between units, we're going to be referring to this page in the book with the common units and their equivalents. Like I said, it's on page 28. And we're going to be referring to this table quite frequently. So you might want to put a little tab or a post-it note, or you can take the time if you want to and write these equivalents on a flashcard. That way they're readily available when you're working through homework problems. So converting between units. We need to get an idea of what the relationship is between inches and centimeters, right? And so based on this table, for every 1 inch equals 2.54 centimeters, right? And we're being asked to convert 17.6 inches to centimeters, okay? So we're going to start off with a solution map. And the solution map is just a simple way of saying, this is where I'm at, this is where I need to go, right? So with our solution map, we're going to go from inches to centimeters. And our relationship is our conversion factor, right? So we're going to go from 17.6 inches. We're going to convert that into centimeters. And we're going to use this relationship, 1 inch equals 2.54 centimeters, to convert this problem, okay? So our relationship here is going to be 1 inch divided by 2.54 centimeters, okay? So we just plug in the rest of the information. Oops, actually I have inverted this. So this goes like this, 2.54. Sorry about that. So we take our like units and they cancel out. So we take our 17.6 and multiply it by 2.54, and it gives us 44.7 centimeters. So 17.6 inches is equivalent to 44.7 centimeters, and that's based on dimensional analysis, okay? The next type of conversion problem that we're going to talk about is a multi-step conversion problem. And you're going to see a lot of these on quizzes and exams. So this is where you really want to identify the steps that you need to take in order to solve the problem. I went ahead and put our relationships here. We're being asked to convert 194 centimeters to feet. And we know when we look at our table on page 28 that we can't go directly from centimeters to feet, okay? So what we have to do is we have to determine, with the use of our solution map, how we're going to convert centimeters into feet. And to do that, we have to go from centimeters to inches, and then from inches to feet. Okay, and then our relationships here, we know that for every 1 inch is equivalent to 2.54 centimeters. And then we know for every 12 inches is equal to 1 foot, right? So now all we have to do is plug in the rest of our information. So we have 194 centimeters. We put our multiplication factor in here. We're going to go ahead and cross out our like units. Let me do that in a different color just so you can identify it better. Okay, so we're going to cross out our like units, which is centimeters and centimeters. And if you'll notice that when you start off with centimeters here, you're going to have the same unit of measure in your denominator, okay? So centimeters and centimeters, and then you have inches and inches, and that way your answer ends up in feet, okay? So when you put this into your calculator, you should come up with, I've already got it worked out here. You should come up with 6.3648. And based on sig figs, we're going to round this to 6.36 feet. So this is our answer. So our next topic is going to be units raised to a power. Occasionally you're going to see problems that include cubic centimeters, cubic inches, cubic feet. It's important to know that when you're converting quantities that are raised to a power, you must raise the conversion factor to a power as well, right? So we know that for 2.54 centimeters is equal to 1 inch. But we're going to work a problem here in just a moment that's in cubic centimeters, right? So we have to convert our conversion factor, we have to put it into, we have to add the power of 3. And so this is what that looks like. So 2.54 centimeters cubed is equal to 1 inch cubed. And so you actually cube 2.54 and you get an answer of 16.387 cubic centimeters. And that's equivalent to 1 cubic inch, okay? And so this is our new conversion factor because we have units raised to the power of 3, okay? So let's take a look at this next problem, which we're going to convert 1,255 cubic centimeters, and we're going to convert that to inches, right? So it's actually going to be converted to cubic inches because this is cubed, this has to be cubed. So the first thing that we do is draw our solution map. So we're going to go from cubic centimeters to cubic inches. Our conversion factor is going to be 1 cubic inch is equivalent to 16.387 cubic centimeters. And remember, when you're working these problems, you always have to include your units. So your cubic centimeters cancel each other out. Our answer is going to be in cubic inches. We're going to divide 1255 by 16.387, and what we get is 76.5851 cubic inches. The correct number of sig figs gives us an answer of 76.59 cubic inches. Okay, so I'm going to go ahead and put some practice problems on the board for you to write down and then pause the video. And then the very last thing that we're going to cover in this video is density. and using density as a conversion factor. So go ahead and get your paper and your pencil handy and your calculator. I'm going to put a few sample problems or homework problems on the board for you to work through, and then we'll compare our answers. Okay, so I've just put 4 practice problems on the board here. There are some multi-step problems here. Didn't put any that were cubed. I figured that was something that you could work through on your own using the book as a reference, or rewinding the video and rewatching the steps that we just took to solve the previous problem. So go ahead and write these down, pause the video, and work through them, and then when we come back together I'll have the answers for you. Okay, on number 2 I had millimeters, I meant milliliters, and so here are the answers. 4,550 grams, 4,550 grams, 18.7 milliliters, 38.4 meters, and 15.7 inches. Okay, so that's just a few practice problems. Your professor does assign homework problems, even though they don't collect them or grade them. They assign the homework problems because this is what they use as a test bank, question bank for their quizzes and their exams. So 9 times out of 10, you see these problems again. So, whatever's on your homework, whether they take the homework problems out of the book or they go through the trouble of creating a homework sheet for you, you need to do them. There is a reason for it, because they pull their test questions from these homework problems. So just keep that in mind as you're preparing for class and going through your lecture notes. There'll be separate files with your homework problems, and they're good to study as well. When you take the time and go through and work them out step by step, then you can get into the habit of carrying your units with you, canceling out your like units, rounding up significant figures, everything that we've learned so far in this video. We're taking this information and we're going to be adding to it for the rest of the semester. So it's very important that you get a good understanding of these unit conversions now, because it's something that you're going to use for the rest of the semester. All right, so let's take a look at density. Okay, so density. The density of an object is the ratio of its mass divided by its volume, right? So your formula for density is D, which is density, equals mass divided by volume. Real simple. Couple of different sample problems using density, using the formula for density. These are pretty easy, so we won't go into it a lot because this video is already kind of long. But if you can use density as a conversion factor. So what we have is we have an item with a mass of 5.84 grams. We have a volume of 0.556 cubic centimeters, and we want to find density in grams per cubic centimeter, right? So using the formula for density, we're going to take our mass, which is 5.84 grams. We're going to divide it by our 0.556 cubic centimeters. That's going, since these are not like units, they don't cancel out. Our answer is going to be in grams per cubic centimeter, right? And it's going to be 10.5 grams per cubic centimeter. So that's the density of this object. So that's just real simple. It's just division. You can also use density as a conversion factor. When working through some of your homework problems, you'll see some problems where you have to use density as a conversion factor. Okay guys, thanks for watching this video. I really appreciate it, and I hope that it's been helpful. That's going to be it for this video. We've covered everything from Chapter 2, which is your first week of class. The next video is going to be over Chapter 3, which is Matter and Energy. So be looking for that video. If you can think of any questions or you need help with tutoring, give us a call here in the TRIO office, and I'd be more than happy to set up a Zoom tutoring session or even a face-to-face tutoring session to help you get through this semester in Intro Chem. It's really a fun class. There's just a lot of math, and so if you have math anxiety, tutoring is definitely going to be beneficial for you. But that'll be it for this video. I hope you come back and watch other videos and that they help you through the remainder of the semester. You take care, and I'll see you next time.